The Cleaning Chronicles, from professionals for professionals.
Hi, my name is Ravi Parthasarthi and I am a senior applications engineer at ZESTRON Americas. Today I will be presenting on the topic that relates to the complex assemblies and the packages that's used in the industry. These complex packages that we'll be focusing on, I will be talking in general about the bottom termination components such as the QFNs and LGAs, as well as I'll be touching upon the power electronics and semiconductors that involves the packages such as 2.5D 3D packages, DCBs, IGBTs, and diodes. First and foremost, when we look at the cleaning of such challenging components, there are important criteria one needs to consider. First and foremost, it's the component size reduction. Secondly, there has been an increased use of lead-free solder. Then there is also the cleanliness specs, which is getting increasingly challenging. So in this presentation, which I'll be covering today, I'll be focusing on this all different types of complex components, which has been widely used in the industry, the factors that affect the cleaning, and then the failure mechanisms which is associated with it. And finally, I'll be focusing or sharing some of my views and case studies that we have come across from numerous customer experiences. The complex packages such as bottom termination components, which includes QFNs, LGAs, MLFs, are the most widely used packages in the industry these days. And these packages, because of the extremely low standoff, they are becoming more challenging and the fluxes get trapped due to lack of outgassing channels, which makes it much more difficult from cleaning perspective. Then there is the case of semiconductors, which involves the power electronics and power modules, where it includes DCBs, IGBTs, and MOSFETs. And in this case, there is a high material metal mix due to a combination of aluminum, nickel, copper, gold, and this high material mix will always or oftentimes result in most likely galvanic corrosion. So in such cases, especially power electronics, it's really important to use the right chemical and the right cleaning equipment, because the chemistries need to have a good corrosion inhibitors in its formulation, which will avoid any kind of galvanic corrosion related failures. The failure mechanisms that we come across when it comes to this type of components are electrochemical migration, then you have corrosion-induced leakage currents, and then there is also, in case of semiconductor electronics, we have to look at the bond strength, the shear strength, and such factors. And another important thing that needs to be also been taken into consideration is the surface energy of the cleaned assemblies after cleaning. Because if the surface energy is not good enough, then you would not have good wire pull, and you will have your shear strength is going to be much lower, so which will definitely cause a failure when it comes to this type of power electronics. So talking about customer case studies, I would like to mention about a military and aerospace customer who are mainly focusing on power electronics. They were making or manufacturing DCBs and IGBTs, where there was an aluminum wire which was bonded to the gold pads. So in this case, when we used an alkaline chemistry, an example of alkaline cleaning agent with improper corrosion inhibitors, we found that the gold pads was reacting and it was forming a white residue corrosion, which was due to impact of galvanic corrosion. So in this case, it was a very critical customer, and they had this high products and high requirements. So we decided to focus on multi-testing of different cleaning chemistries, and we were able to narrow down to a pH neutral formulation, which was able to successfully remove the flux residues, as well as add enough corrosion inhibitors in its formulation, which was able to completely avoid the formation of galvanic corrosion related failures. So this process eventually was subjected to several qualification and verification tests and was finally implemented at customer site, and the clean substrates were later on subjected to electrical testing, which finally was able to meet the customer's requirements, and the process was successfully implemented. Finally, for more information, please feel free to contact ZESTRON's Application Technology Department. Thank you.